The last 2 or 3 decades has seen a huge growth in the number of microwave ovens found in homes and institutions everywhere across the world, actually. And I want to take some time now to explain how it is that microwaves work, why you can't put metals in microwaves, and why just because you can smell food coming out of the microwave doesn't necessarily mean that the microwaves are leaking out. Now, microwave ovens, well, the technology behind it was actually discovered by accident. This happened during World War II. There was an American engineer working for a defense company working in radar. His name was Percy Spencer, and what he noticed was that as he was working with this radar equipment, which was actually operating in a microwave range, that he found the chocolate bar that he was carrying in his pocket melted. And that got him thinking, and eventually the company he worked for, Raytheon, developed the first commercial microwave. Now, the first thing they tried to use to microwave was popcorn, which worked quite well. The second thing they used was an egg. Now, anyone who's ever put an egg in the microwave will realise what happens when you put an egg in the microwave. It explodes, unfortunately. Literally, you end up with egg on your face if you're not careful. And that's to do with the superheating that goes on within the egg as the energy is trapped inside it. And it can't escape because of the shell around it. So, the first commercial microwave was 6 foot by 6 foot. It cost $5,000 which in the late 40s was an incredibly large amount of money. And unsurprisingly, you didn't see them up and down in homes across the country. As the technology has developed, microwaves have become smaller and become more powerful. They've certainly become a lot safer. If you stand near a microwave now and you have a chocolate bar in your pocket, it really shouldn't melt at all. If it does, it's probably due to your body heat and not the microwaves. At least one would hope so. So how do they work? Well, the electricity comes in from the mains. That's normally around 230 volts. And inside the microwave, then that is transformed up to 3,000 volts. So it's a very high voltage that we're working with here. Then it uses something called a magnetron. And what this does is it turns this high voltage electricity into electromagnetic radiation. It turns it into high frequency microwaves. Now, to understand that, we need to appreciate the electromagnetic spectrum. Now, this is basically the spectrum of different types of electromagnetic waves, and they differ in terms of their wavelength. So the longest wavelengths are things such as radio waves, and then you go through microwaves, which is what we're talking about, and there's infrared, visible light, which we used to see, ultraviolet light, and then X-rays, and then gamma rays. Now you have the smallest wavelength down in the X-ray gamma ray region, but they also contain the highest amount of energy. And so we're using this microwaves thing, and the frequency that's actually chosen is 2.4 gigahertz. That means that the wave is traveling at roughly a frequency of 2.4 billion times a second. The reason that that was chosen actually was so that it wouldn't interfere with FM radio, shortwave radio, because the problem is that the wavelengths are actually quite similar, and so that frequency was chosen in particular to avoid that. Microwaves are used not just in ovens, it's also the technology that's used to connect your mobile phone to the base station nearby. So it's the same kind of technology, and that's why actually one of the reasons why mobile phones get hot when you're using them for a while. It produces the heat. So the food absorbs these microwaves because they're being fired out by the magnetron into the chamber. Now, the chamber is covered in reflective things, such as steel, and other reflective components. Now, this will bounce the microwaves around so it accesses all areas of the food. Now, it's actually dangerous not to put something in to absorb the energy. If you operate a microwave when it's empty, what you get is a huge build-up of energy because there's nothing to absorb these microwaves. You end up with burning, and it can potentially lead to a fire within the microwave. This certainly might well lead to the microwave breaking, so that's not a great idea. The way that it heats the food is via a method called dielectric heating. Now, this happens when you have a molecule which is charged positively at one end and negatively at the other. Now, when you apply a magnetic field to this molecule, the molecule wants to rearrange itself so it's facing in line with the magnetic field, just like a compass needle will tend to point north. Now, if you change that magnetic field, say to the opposite direction, the molecule then has to spin around, turn around, so it's facing the other way. Now, if you imagine that this magnetic field then is changing incredibly rapidly, and if you imagine you have many, many molecules doing this, they're always turning and changing. Now, this produces friction between the molecules as they vibrate. Now, it's this friction that leads to heat, and so the more the molecules vibrate, the more they warm up. In fact, that's the way that we measure temperature, is how much the molecules are vibrating. So the lowest temperature we know of, 0 degrees Kelvin, minus 273 degrees Celsius, that's when, it's called absolute zero, it's when the molecules are stopped. And the idea behind that is that they're not producing any heat energy. And then as we go up the temperature, then these molecules start vibrating, and it's that friction that produces the heat. Anyway, so it's that dielectric heating that heats what you have in the microwave. Now, a common misconception is that it's just the water that the microwaves resonate with. But that's not actually true. If microwaves were designed to resonate 100% with water, what you'd end up with is that the water molecules on the outside of your food would cook very, very quickly. In fact, they'd superheat, and the food inside it wouldn't actually get cooked at all because all the microwaves would be absorbed by what's on the outside. So it's chosen for its average food depth, penetration depth. So it's actually the frequency and the energy is chosen to try and penetrate the most throughout your food. So it heats these polarized molecules, any polarized molecule. So it includes fats and it includes sugar, anything with that positive and negative charge that I was just talking about. So that's the way that you have dielectric heating. Microwaves are incredibly efficient, and that's because they don't heat the air in which the chamber is. So if you've got a normal conventional oven, then that heats all the air around the food as well as the food, and that can also lead to a kitchen becoming very hot. A microwave doesn't have that, it just heats what you have in the middle of it. So why shouldn't you put metals in the microwave? Well, the microwaves you've turned electricity into microwaves in the magnetron. The problem is with putting metals in is that you can turn the magnetic waves back into electricity. It can cause currents to flow, and this may cause them to heat up, and it may cause sparks to fly, and it may cause a fire. So it's that interaction between electricity and magnetism. In fact, it's electromagnetic waves, it's all in that name, that can cause a fire to start if you put metals in a microwave. So the electrons can transfer very quickly between metallic substances. In very thin metals, fires are more likely, and particularly where there's a sharp point, and that's when charge can build up, and that's where you get mini lightning strikes, also plasma strikes. As you get between two spikes, you can get a plasma ball forming in a microwave. Now that you can do just by simple experiments using even conducting materials such as grapes. However, that can be extremely dangerous. It can cause many fires as well as breaking the microwave ovens, so it's entirely not recommended to try that. So, why do you have a spinning plate in a microwave? Well, the reason why you have a spinning plate is you've only usually got one magnetron, and it shines waves into the microwave in a particular direction, and they do bounce around to try and catch every area of it. But you want to get an even coverage, and so by having a spinning plate, it increases the evenness of the heating, so that you end up with food that's cooked evenly. Sometimes you may have a browning plate. This is normally a reflective substance placed underneath the food, and this can be used to brown a pizza because it reflects underneath the food more microwaves, so you're actually getting more heating in that area than you would do in other areas. So you can actually use reflective materials to reflect some of the heat, such that you can cook things in different ways. You can make things crispier if that's the way you like them. So, is it dangerous if you smell the food? Because does that mean the microwaves are leaking out? Well, the answer to that is no. Microwaves have a wavelength of about, say, 10 or 12 centimeters, whereas air is much, much smaller than that. And so whilst air can escape from microwaves, you'll notice a grill on the front of your microwaves. Now, this is used to prevent the microwaves escaping. And so if you actually measure microwave radiation outside a microwave for any good microwave that's not broken, you'll detect very, very little, in fact, probably zero change in the microwave field outside a microwave as you will to another area of your kitchen or another area of your house. And so if you smell your food, it's still very safe to eat it and to go near your microwave. The dangers involved in microwave heating are actually not to do with that. They're also not to do with cancer because this is non-ionizing radiation, so it doesn't have any effect on causing cancer on the food. It's more to do with heating. In particular, if you put a glass of water into the microwave, it can lead to superheating. This is where the fluid raises it in a temperature over 100 degrees but doesn't boil off. And when you then come to take it out of the microwave, it can evaporate into steam very, very quickly, and this can be very problematic. So that's the dangers involved in microwave heating, but generally it's a very safe way of cooking food as well as being very energy efficient. The question I want to leave you with today is this: how can you think microwaves can be developed to cook food quicker while still being safe? What kind of technology improvements can be used? What will they be developing in the next 10 or 15 years? Have a good think about it. Thanks for watching.